Okay, so today's notes, day 6 notes, are going to cover logarithmic equations. Last notes we took had exponents in them, exponentials. Today's equations are all going to have logs. First thing that you need to know is what is called the one-to-one property. Here's what the one-to-one property says. If I have one log set equal to one log, that's important, one log only, and the bases are the same, then the arguments have to be equal. Now, I would like you to write down, there's 2 things that are necessary for this in order to use this property. First of all, it's one log set equal to one log. Secondly, we need to have the same base. If you have one log set equal to one log and both logs have the same base, then the arguments are equal. Okay, so example 1, solve each logarithmic equation. What we're going to notice is we have one log set equal to one log. Do they have the same base? Yeah, what's the base here? 10. Okay, so same base. And that base is 10. So what that means is we can set the arguments equal. And that's what we're going to solve. If I move the x over, I get 2x. And then if I move the 1 over, I get 8. So I get x equals 4. Now, you do have to do a little bit of a mental check. In a log, the argument always has to be greater than 0. So when you get your answer, what you need to do is you need to plug it back into every log and make sure that those arguments end up being greater than 0. So the first one ends up being positive, the second one ends up being positive. I don't need to see any work for that. If you can do it in your head, that's fine. But you always have to do that. Anytime you have an equation with a log in it, you got to make sure when you plug your value of x back in that the argument is positive. So that was A. B, we're going to notice we have one log on the left, we have 2 logs on the right. All the logs have the same base. What's the base for each log here? E. Does that mean I can cancel out all the logs because they have the same base? No, why not?
Because there's 2 logs.
2 logs on the right side. So, is there any way for me to put these 2 together to make it 1 log? Yes, Maria? Multiply. So this is going to become the natural log, and now I can multiply the arguments. 2x plus 2 times x minus 2. Now I have one log set equal to one log, and both have the same base. Now I can set the arguments equal. So I get 3x plus 8 is equal to 2x plus 2 times x minus 2. Okay, I'm going to warn us this one's going to definitely be some more work to solve. What are we going to have to do at this point? Yeah, we're going to have to multiply out on the right side. So when we do that, we get 2x squared, add 2x, subtract 4x, subtract 4. What I'm going to do while I'm at it is I'm going to move the 3x and the 8 over. So I get everything set equal to 0. So I have 2x squared. So then 2x and a negative 4x is negative 2x. Negative 2x and a negative 3x is a negative 5x. And negative 4 subtract 8 is negative 12. Okay, what are we going to have to do at this point? Factor. Yep, factor. I split the middle. Some of you factor differently, but I split the middle. So I look for 2 numbers that multiply to negative 24, but add to negative 5. Hopefully we can see those numbers are negative 8 and positive 3. So then I bring down the first term, bring down the last term. On the left side, I take out a 2x, and I'm left with x subtract 4. On the right side, I take out a 3, and I'm left with x subtract 4. Martina, how do I know I'm on the right track?
You have both of the things in the parentheses. They're the same.
Yeah, stuff in the parentheses is the same. So one factor ends up being 2x plus 3, and the other one ends up being x subtract 4. So when I set those equal to 0, I get negative 3 over 2. Oh, it's kind of hard to read. So negative 3 over 2, and then I get a positive 4. Am I finished? No, definitely not. We need to make sure that we take both of those answers and either in our head or writing down, plug them into all three arguments and make sure all the arguments are positive. Are there any issues with either answer and any of the logs?
Shouldn't you like simplify that x equals negative 3 over 2? Oh, sorry.
Maria?
Negative 3 over 2, when you plug it in the math, like x minus 2 is less than 0.
Okay, definitely. If we plug negative 3 over 2 in here, this should be an easy one. A negative number subtract 2, still going to be negative. So this negative 3 over 2 does not work. 4 should work in all of the logs, and so our only answer is x equals 4. Now, it's possible for there to be two answers, but in this case, one of the answers does not work. Do you remember what that's called when you do all of your math correctly, but one of the solutions just doesn't work?
No solution.
There's a special word for the solution. Starts with an E. Nobody? Extraneous. It's called an extraneous solution. Okay, that's the first type of problem you're going to see. Questions on that before we look at the second type of problem? Okay, second type of problem. You're only going to have a log on one side of the equation, like in example 2a. Example 2a, there's only one log. So we can't cancel that log out because there's not a log on the other side. If that's the case, like it is here, there's really nothing we can do the way that the equation is currently written. So we're in log form, there's really nothing we can do. And so what we do instead is we switch forms. So we're in log form, we're going to put it in exponential form. So we have our base, our argument, our exponent. So this gives us 2 to the 5th equals 9x minus 1. 2 to the 5th is 32. So we get 33 is equal to 9x. I divide by 9. And I can simplify. I divide by 3 and I divide by 3. So my answer ends up being 11 over 3. Same idea, you do need to plug it into the argument and make sure that the argument ends up being positive, which here we can see it clearly will be. Okay, last example is example 2b. Okay, can I cancel the logs out? No, why not? What is the issue in the equation? What prevents us from canceling the logs out? The 2 and the negative. This is the problem, so I can't cancel the logs out. Can I switch forms? How? What's my base? What's my argument? I got too much going on. So instead, what we're going to do is it might be helpful if we were to move this log to the other side. So we're going to have log of x, add log of x plus 15 is equal to 2. We already decided we can't cancel the logs out. can we switch forms at this point? What should we probably do before we try to switch forms? Yeah, combine these two logs. They have the same base, so let's put those together. We get log of x times x plus 15 is equal to 2. I'm going to multiply that out just to make my life a little easier. So when I distribute that x, I get x squared add 15x. Okay, now what? Yeah, switch forms. Don't cancel this log out. That's what a lot of people want to do. They want to write x squared plus 15x equals 2. That's not the case. There's no log on the right side. Instead, switch forms. If there's no base written, remember the base is understood to be a 10. So we have base argument exponent. So we get 10 to the second equals x squared plus 15x. 10 to the second is 100, so if I move 100 over, I get x squared plus 15x subtract 100. Okay, so for factoring, we are looking for two numbers that multiply to 100, negative 100, but add to 15. Are there two such numbers? 20 and negative 5. This one is pretty nice. Because we have a 1x squared, we don't have to split the middle. We can jump right to x plus 20. X subtract 5. So when we set both of those equal to 0, we get x equals negative 20 and x equals 5. Do both work? No, Allie, why not?
Because the negative 20 on both the arguments still stays negative.
Okay, so that negative 20, if we plug it into just the first log even, our argument ends up being negative. So negative 20 will not work. 5 does, though. I want to caution you, what some people do is every single negative answer they cross out. Some negatives will work. So please do not just assume that because x is negative, it's not going to work. That's not the case.